Hello viewers, I am Dr. Mercy Anthony, Assistant Professor and Head, Department of Statistics from St. Joseph's College of Arts and Science, Autonomous, Cuddalore. I hope you will find this video informative, and by the end of this video, you will be able to understand the concepts of classification and data types. To begin with, first we'll understand what statistics means. So definition of statistics goes like this: the science of collection, presentation, and analysis and reasonable interpretation of data is known as statistics. For understanding data, statistics offers a thorough scientific approach. For example, suppose we measure the weight of 200 students in a class for a study. With so many measurements, simply looking at the data, we fail to provide an informative account. However, statistics can give us an instant overall picture of data based on graphical presentation or numerical summarization, irrespective to the number of data points. Besides data summarization, another important task of statistics is to make inference and predict relations of variables. Next, we will see what are the types of data. So basically, there are two types of data. First one is primary data, second one is secondary data. So the first is primary data. What is primary data? Primary data is the data that is collected for the first time through personal experiences or evidence, particularly for research work. It is also described as raw data or first-hand information. The data is mostly collected through observations, physical testing, mailed questionnaires, surveys, personal interviews, telephonic interviews, case studies, and focus groups, etc. Next, we'll see what is secondary data. Secondary data is the second-hand data that is already collected and recorded by some researchers for that purpose and not for the current research problem. It is accessible in the form of data collected from different sources such as government publications, census, records of the organizations, books, journals, articles, websites, etc. Next, we'll see what is classification. As the name goes, classification is the process of arranging data into homogeneous, which means similar, groups according to their common characteristics. Raw data cannot be easily understood. So now here the question arises, what is the use of classification, or why do we need to classify the data? The reason for this is raw data cannot be easily understood and it is not fit for further analysis and interpretation. Arrangement of data helps users in comparison and analysis. It is also important for statistical sampling. Next, we'll see what are the types of classification. There are four types of classification. First is geographical, second is chronological, third is qualitative, and next is quantitative. First, we'll go for geographical classification. When data are classified on the basis of locations or areas, it is called geographical classification. For example, the production of wheat in different countries are listed below. So the countries' names are in the first column, and then second column I had given the wheat production of wheat per area or per acre in kilograms. So the first column refers the countries where it is, for example, America, China, Denmark, France, and India, and the production are given in the second column. Like in America, it is 1925. In China, it is 893. Next, what is chronological classification? In chronological classification, the data are classified according to the basis of time, months, and years. For example, I've given the example of the estimate of birth rates in India during 1970 to 1976. So the first column here refers the year, and the second column, the birth rate, refers the the birth rate of that year, particular year. Next, we'll see what is qualitative classification. As the name goes, it is qualitative classification. So the data is based on the quality, such as gender, color, literacy, and religion. So here what we have to keep in mind that the quality which cannot be measured comes under qualitative classification. So here I have given you the example of population. The whole population is divided into male and female. And again, the male and female are again subdivided into two categories, employed and unemployed. So this is all about qualitative classification. Next, we'll go for the fourth type. It is quantitative classification. So the quantitative classification, the data are segregated according to some characteristics like height, weight, profits. And here what you have to remember is we can here measure the value. The value which can be measured comes under quantitative classification. So I have given you the example of the student of a college may be classified according to the weight as given below. So the weights of the students are given in the first column. Second column denotes the number of students. Like for example, the weight of the first category students from 90 to 100. So the number of students is 50. So these are the this is the example for quantitative classification. Next we'll see quantitative classification types. So in quantitative classification, we'll be having two types of classification here. The first one is discrete frequency distribution and the second one is continuous frequency distribution. In quantitative classification, there are two elements. First is variable, second one is frequency. Now we'll see what we know about variable. So variable refers to the characteristics that varies in magnitude or quantity. For example, weight of a student. A variable may be discrete or continuous. Next, we'll see what is frequency. Frequency refers to the number of times each variable gets repeated. For example, there are 40 students whose weight is 60 kilograms. Here 40 students is the frequency. Next we'll see what is frequency distribution. Frequency distribution refers to data classified on the basis of some variables that can be measured, such as prices, weight, height, wages. Here I have given you the example for weight in kilograms and the number of students. Next is frequency distribution. So now frequency distribution, when a continuous frequency distribution is formed, the following terms are important here. So the first is class limits, second is class interval, third is class frequency. So first we'll see what do we understand by class limits. So I have given you here the example of weight in kilograms and number of students. So the weight goes like 31 to 35, 36 to 40, 41 to 45. And the number of students are 10, 8, and 12, so on. So for example, take the class 46 to 50. If I am taking the class 46 to 50, the lowest value of the class is 46. And in that class, the highest value is 50. So what happens is, no value will be lesser than 46 in that class interval, and no value will be more than 15 that particular class interval. So 46 is known as the lower class limit and 50 is known as the upper class limit. Next, we'll see what is class interval. The difference between upper and lower limit of the class is known as class interval of that class. Then the class frequency. The number of observations corresponding to a particular class is known as the frequency of that class. Next, while calculating the problem, we'll come under three types of data. The first one will be raw data, or which is also known as individual series. Second one is known as discrete series. Third is continuous series. And in continuous series, we'll be having two types. First is inclusive method. Second one is exclusive method. So the first one, raw data or individual series. So as the name goes, raw data So anything which is unprocessed, that is known as raw. Or the second name goes like individual. So the individual values are known as individual series. That value comes under individual series. So I've given you one example of 10 laborers in a factory. The daily wages are given like 150, 250, 125, 275, and so on. So this raw data gives a rough idea of the distribution of the items over the range. When we have a large number of variables, the analysis of data is very difficult in raw data as the numbers are huge. Next is discrete series. So in this form of distribution, the frequency refers to discrete values. Here the data are presented in a way that exact measurements of units are clearly indicated. So this is the example for discrete series. For example, the marks and number of students are given to you. Now in marks it is 25, 35, 45 and so on, and number of students it is 2, 5, 10. So here in this example, it is specifically given that 2 students have scored 25 marks, 5 students have scored 35 marks and so on. Next we'll see what is continuous series. So in continuous series, in this form of distribution, values are given in class intervals. This becomes necessary in the case of some variables which can take any fractional value, and in which case an exact measurement is not possible. So for example, marks and number of students are given here. The values are 10 to 20, 20 to 30, 30 to 40 and so on. So the first value, the 10, the value which is starting value is known as the lower limit, and the value, the ended value is known as the upper limit of the one class. So if the next value 20, this same 20 is the lower limit for one class, the first class. When it comes to the second class, it becomes the lower limit of the next class, and the 30 now becomes the upper limit of the one class. When it comes, this 30 when comes into third class, now you can count and see the value starts from 10 to 20, 20 to 30 and 30 to 40. So the third one, third column, the 30, the same 30 which was the upper limit for the previous class becomes the lower limit for the next class. So this is all about continuous series. And now the continuous series, as we saw in the previous slide, it was of two types, inclusive and exclusive method. So in inclusive method, as the name itself defines, inclusive is the meaning that the values are included in that class interval. So in this method, the overlapping of the class interval is avoided. Both the upper and lower limits are included in the class interval. So you can see this example, the first one, the class interval is 5 to 9. The next class interval is 10 to 14. So now you can see that the 5 to 9, the 9 value becomes the upper class limit of the first class interval. It don't come to the next class interval. So the next value 10 is the lower limit of next class interval. So that is all about inclusive method, where the upper limit won't become the lower limit for next class interval. When it comes to exclusive method, the class intervals are so fixed that the upper limit of one class is the lower limit of the next class. So that you can see in the second example, where expenditure and number of families are given to you. The first class interval is 0 to 5,000, and the next class interval is 5,000 to 10,000. So the first value 0 to 5,000, in that 5,000 is the upper limit for the first class interval. When it comes to second class interval, 5,000 to 10,000, that 5,000 becomes the lower limit for the second class interval. So this is the difference, basic difference between inclusive and exclusive method. So thank you for your attention. Hope this video will be useful for you.